I'm waiting to see if Jin-Yi is going to kick it off. If not, we'll just get started. I think it's still calling people in. So let's get started on. Welcome to the first panel at this wonderful event. I'm of course delighted to be here and organizing this panel with these excellent panelists whom I'll tell you about in a minute. But first I want to thank Jin-Yi for this opportunity to do this panel, to be here in Buffalo and to be part of this wonderful celebration. I also want to thank Professor Steve Kahn for his inspiring keynote this morning. I think he set the backdrop so beautifully for us. It's going to be fairly easy for every one of these outstanding people to connect to a lot of the themes that he alluded to, everything from curiosity to ethics in research. And I think there are so many beautiful themes that he alluded to. It's going to be fantastic to hear these top people connect to these things. The goal of this panel is to talk about hot topics in computing, right? It's up to us to define what a hot topic is. I'm going to let these people define it in their own terms, what hot topic or what their field is. They're going to define it for us very broadly or very narrowly, depending on their perspective. I'll introduce them to you in a minute. But this is really a panel about computing, about the glorious achievements in computing, the wonderful things that are happening at a breakneck pace every day in academia, in industry, in research labs, every imaginable section of the computing innovation spectrum. And this is a wonderful cross-section of that. We'll get to the details in a minute, the format and all of those things. But most importantly, it's a panel for every one of us here, which means that I expect all of you to be closing your laptops. I have one of my buddies there with his laptop open. As much as we love mobile computing and technology, put your smartphones away. They can wait a little bit, and tune into this. Ask them really, really great questions. No question is too easy or too difficult. So go ahead, ask them. It is from these questions that we're going to draw great insights from these panelists, and hopefully there'll be a couple of controversial questions, right? Go for it, and in turn, I expect them to throw a bunch of controversial questions to each other. Keep it light, keep it interesting, keep it informative. Hopefully we'll all have a memorable hour ahead of us. Okay. Right. Before I get into describing them, I must first stop and Jin-Yi, everything's good? Yeah, awesome. I must stop and at the very outset apologize for something that's really, really a fundamental mistake on my part. If you look at the panel, as wonderful as every one of these gentlemen are, they're gentlemen. Right, I failed in my duty, mea culpa, completely. I did try, but yes, Kanan, we'll talk about that later. I did try, but clearly I did not try hard enough, and that is certainly not right. And hopefully, when we do the 60th anniversary celebrations, it'll be an all-women panel here. Right? All right. So now let's get started. The way you have a lot of panelists here. We have 8 of them. One of them couldn't make it. Faisal Farouk from IBM couldn't be here. So we have 8 panelists here. And just to give you a mental map of how I'm thinking about this, in the middle we have what I consider the core infrastructure of computing. We have Professor Jin-Yi, whom we all know and love at Buffalo. He was a faculty member at UB in the 90s. He's now a professor of computer science at University of Wisconsin-Madison. He's an outstanding expert in computational complexity theory. And hopefully most of you got to see his talk yesterday outlining his research program. So let's give a warm welcome to Jin-Yi. Next we have Sridhar Seshadri. He's chief architect at Synopsys. Synopsys, he'll tell you more about this in a minute. Synopsys, for those of us that don't know what it is it's where hardware begins. I think if you saw Professor Kong's talk about all these big diagrams of 40-foot by 40-foot description of a computer chip, verifying it is a huge, daunting challenge, and that's where Synopsys comes in, and Sridhar will tell us more. Sridhar was a UB alum from the early 90s. Let's welcome Sridhar Seshadri. We also have Ashish Naik. Ashish did his PhD at UB, graduated in 1994. He and I overlapped here for a couple of years, 3 years actually. Ashish has worn multiple hats. Ashish has been a postdoctoral fellow at the University of Chicago. He also worked at Synopsys for a while. He did multiple startups in the Silicon Valley. Now he's at Google, where he works on what is one of the least well-known things about Google, the networking and the systems infrastructure, right? We hear all about cool YouTube videos and fancy search algorithms and data mining and recommendations and Android phones and everything. But underlying all that is the wonderful platform that Ashish and team have done. Let's welcome Dr. Ashish Naik. So that's the infrastructure layer, right? And here I have what I consider the information algorithms layer. So we are looking at computing at a slightly higher perspective here, and to represent the information algorithms layer, which is all about transforming data to information to knowledge. I think again that was a theme alluded to earlier today. We have Professor Jian, who is at Simon Fraser University. One of the world's foremost experts in data mining. In fact, he literally wrote the book on data mining with another legend in the field, Jian, and that's considered the authoritative book in data mining. And Professor Jian spent a few years at UB here, familiar face to many of you. Thanks for being here. Next we have Anmol Bhasin. Anmol was a graduate from UB in the mid-2000s, and now he's Senior Vice President at Salesforce, where he works on search and discovery. And again, he's going to tell us more about what that means to him, what that means to the field of computing, and so on. Welcome, Anmol. On that table over there, I have what I call the extroverted face of computing. Right? So these are the guys that look deep inside computing. They're the foundation and they're the extrovert. But by no means are these distinctions that sharp or clear. The first person I'm going to introduce there is Dr. Bahl, who was a UB student in the 80s, I guess. He's a distinguished scientist at Microsoft Research, where he manages the networking research group and the mobile computing group as well. He's got a very, very broad spectrum of interest. And yesterday you probably saw a lot of his work on video analytics and areas like that. We're pleased to have you here. We have Rob Myers sitting next to Victor. Rob's from the IBM Buffalo Innovation Center. I don't know how many of you knew there's an IBM Buffalo Innovation Center in Buffalo, and he's a senior architect at BAC, and he's going to tell us about, again, he's going to define it much more precisely, but broadly think of it as the connections between computing and the enterprise world. Right? We think of computing as code and programs, things that we compile and run, but there's a greater business world out there that uses computing in fundamental ways, and that's one of the things that I hope Rob will get to. Welcome, Rob. We have Justin Delvecchio, who works for Kubrick, who are also one of the sponsors, I guess, for the event today. Kubrick's a company based in Buffalo, and Justin's work and his organization's work has a lot to do with government, the Department of Defense, and he's going to give us a perspective from the other side of the computing world, government policy, what the government's interested in, what kind of influence we can have. Think of that block as people who can tell us about the influence of computing on society at large. So that's kind of the stage is set. Let's welcome Justin first. Yeah. The format is going to be this. We'll start with the middle block and then tell us about a couple of minutes each about their own research in their own words, how they define it, how they perceive it. The two lenses I asked them to look at are tell us what it is. What are one or two things that happened in the previous decade, in the last decade, that you consider the most significant accomplishments in the field? And use that as a springboard to talk about what are one or two things that will happen in the next decade that you think will shape the world of computing. So they're going to tell us a little bit about these. And once they're done, the three of them, others will start attacking them maybe, or ask them interesting questions. But as I said, it's your panel, so please feel free to put your hand up, we'll bring one of the microphones to you, ask questions, and let's engage in a great conversation. So with that, finally I should say, why are you doing this, right? I was a UB grad in the 90s. I started working at CDIT for a couple of years. Then I started working with Ken Regan, who inspired me to work in theory. I worked with Jin-Yi. And in fact, it's a little known, not so little known fact that I have actually co-authored papers with everyone in the middle table. So So yeah, so I worked here, then I was a member of the faculty of computer science at a large urban public university in Texas. So I have that experience. Then I went to IBM Research where I worked for about 6 years, so I have that experience checked off. Then I worked at Google I'm at Google Research, I've been there for about 12 years. So in particular, it gives me the license to kind of attack faculty, research labs, companies, Silicon Valley, what have you. And I'm also fully buzzword compliant. AI, ML, big data, that's the kind of stuff that I do these days. Again, so I can throw pot shots at these fields as well. So I'm all set for going with this.